Good evening. Dear student, in the previous video, we have learned that every body in this universe attracts every other body with a force which is called gravitation. And the gravitational force between two bodies is directly proportional to the product of the masses of the two bodies and inversely proportional to the square of the distance between them. So, if the mass of one body is doubled, keeping the distance between them constant, the gravitational force between the two bodies will also be doubled. But if the distance between two bodies is doubled, the gravitational force between two bodies is reduced, is decreased by the square of the two, that is 4 times. It means the gravitational force in new situation will be 1/4 of the gravitational force in the previous situation. Today we shall discuss what is a freely falling body, what is acceleration due to gravity, and we shall also calculate the average value of acceleration due to gravity. Now, if Newton's law of gravitation is valid, and if all the objects are attracting each other, then why don't we feel it? Why don't we experience it? Why we cannot detect it? Why we cannot notice it? This is because gravitational force between two ordinary masses, that is between two bodies having small masses, is very small and cannot be detected easily. Let's see, for example, consider that there are two boys of masses 40 kilogram each, sitting at a distance of 1 meter apart. Let us calculate the gravitational force between these two boys. So, gravitational force between two bodies is equal to J into m1 into m2 over d square, where m1 is the mass of the first body, m2 is the mass of the second body, d is the distance between them, and g is, higher case g is universal gravitational constant, whose value is 6.673 into 10 to the power minus 11 Newton meter square per kilogram square. So let us calculate. F is equal to 6.673 into 10 to the power minus 11 into 40 over square of 1. The distance is 1 meter. If you calculate the force between the two boys of masses 40 kilogram, this force comes out to be in the order of -7 Newton. 10 raised to power minus 7 Newton. The approx value is 1.06 into 10 raised to power minus 9 Newton, sorry, 1.06 into 10 raised to power minus 7 Newton, and you can see that this is so small force that it cannot be detected easily. So that's why the gravitational force between two ordinary masses is unnoticeable to us. Now let's see what's a freely falling body. It is a common observation. Then when a body is released from a certain height from the surface of the earth, it descends, it begins to fall toward the surface of the earth. Obviously, this body falls towards the surface of the earth due to gravitational pull of the earth. When earth exerts gravitational force on any object, it is specifically called gravity. That is, gravitational force exerted by the earth is called gravity. Now, when a body descends, that is, it falls, there are practically two forces acting on it, and these two forces act in opposite direction. Number one, the force of the friction of the air, which act in the vertically upward direction, and the force of the gravity, which act in the downward direction. And it is the reason why when a paper is released from a certain height, it descends very slowly. But if the same paper is crumbled, it descends fast. Because the force of the friction of air on a paper is large as compared to this force on a ball of a small size. Now, if we assume that the force of friction of the air is non-existing, it is not acting on the body, then there is only one force, that is the force of the gravity acting on this body. It means in the absence of friction of the air, the body is falling under the influence of gravity only. This body, which is falling under the influence of gravity only, is called freely falling body. So in case of freely falling body, we assume that there is no force except the force of the gravity acting on the body. And you have learned in the previous lesson that when a force acts on a body, an acceleration is produced in it. So acceleration produced in this body due to gravity is called acceleration due to gravity, and it is denoted by lowercase g. What is acceleration due to gravity? The acceleration produced on a freely falling body due to the force of gravity is called acceleration due to gravity, and it is denoted by lowercase g. Today we shall calculate average value of acceleration due to gravity on the surface of the earth. Consider, this is the earth of radius r, and it is a body on the surface of the earth. The mass of the earth is higher case m, mass of the body is lower case m. Okay? So gravitational force between the earth and the body is given by relation F is equal to G into M over R square. So this is the gravitational force between the body and the earth. Now the same force is producing acceleration in this body, which is called acceleration due to gravity. And this acceleration due to gravity, according to Newton's second law of motion, is equal to F is equal to m into acceleration due to gravity. Now comparing both equations, we have mg is equal to g into m over r square, or g is equal to g into m over r square. So you can calculate the value of g on the surface of the earth using this relation, where higher case m, mass of the earth, r, radius of the earth. Now mass of the earth is approximate 6.0 into 10 raised to power 24 kilogram. Radius of the earth is approximate value 6.4 into 10 raised to power 6 meter. If you calculate, the value of the g comes out to be approximately 9.8 meter per second square. So the average value of the g on the surface of the earth is 9.8 meter per second square. That is, when a body is released from certain height from the surface of the earth, it experiences an acceleration equal to 9.8 meter per second square. That is, its speed will increase by 9.8 meter per second per second. Dear student, usually in practice, we do not differentiate between mass and weight, though they have entirely different meanings. Mass is the quantity of matter contained in a body. It is a scalar quantity and its SI unit is kilogram. the force with which Earth attracts a body towards its center? What is weight? Weight is the force with which Earth attracts a body towards its center. Obviously, weight is a force with which Earth attracts the body towards its center. Obviously, it will be equal to mass of the body times acceleration due to gravity. Therefore, weight of the body is equal to mg, where m is the mass of the body and g is acceleration due to gravity, whose average value is 9.8 meter per second square. SI unit of weight is Newton. Remember, mass of a body does not change. But since weight is a force and the weight depends on the value of g, and the value of g varies at different places on the earth, therefore weight of a body is likely to change. On the pole and on the equatorial region, the weight of a body is found to be different. This fact we shall discuss in the next video. Thank you.